Non-equijoins. Non-equijoin is a joint condition containing something other than an equality operator. The relationship between the employees table and the job table is an example of non-equijoin. The salary column in the employees table ranges between the values in the minimum salary and maximum salary columns of the job table. Hence, each employee's salary can fall within any range. The relationship is obtained using an operator other than a quality operator. And so the operator will probably use in that one now is between. So I'm going to use two tables for this one. I'm going to use two tables, and that is the jobs. Look at this job table. I click on data. Look at this job table. We have job ID, job title, minimum salary, and maximum salary. So for every job title, say president, the minimum salary of a president is between 20,080 to what? 40,000. 15,000 to 30,000. Look at this one is from 20,000 to 40,000. This is from 15,000 to 30,000. So already this administration is already overlapping this president. Are you seeing it? Now, this query, this non-equijoin is sometimes used when you look at grading. Like in school, a particular student has a mark, and then you want to give it a grade. Say A, this range to this range is grade A. From this range to this range is grade B. In such a case, there will be no overlapping. So for A grade, from 80 to 100 is A grade. From 70 to 80 to 79, right, is B grade. From 60 to 69 is a C grade. From 50 to 59 is D grade, like that. That is where you use this kind of query that I want to show you, non-equijoin for. Are you with me? But we don't have any table that contains grade. So we can't do that. So I'm just going to use this one because in this job, we have minimum salary and maximum salary. So there's a range. And anytime you are looking at the range, I taught you in one of my classes, the operator you use for range is between this and this. So between the minimum salary and the maximum salary, you can get whatever it is that I want to show you. So let me just click on this and just show you the query I'm talking about. So I can say select last name, last underscore name. That is just what I will do, comma, salary, comma. Then in the let me write that. I'll say select star from jobs. That is the table. I will end this. When I run this, this is the job table. So the job table is having job ID, job title, minimum salary, maximum salary. Now this is the query I'm now typing. I want to see the range. Select last name, salary, job, job underscore ID, or no need for. Okay, I can do that. Then no need for that. Let me just say job title, job underscore title, right? From employees. I want to join these two tables together. I want to join the employees table and the job table. From employees, join. This one is just two tables. So just one join condition. Join jobs. Are you with me? Okay, join jobs. This one is just one table. On. Now, what I want to say is that I'll say salary. I'm calling, in this case now, we are doing non-equijoin. What I want to find out is, like this president, this Stephen, 24,000. What range of job title can it be with this 24,000 naira salary? What range of job title can this president be? Now, if you have this one, different job titles are president, administration vice president, administration assistant, finance manager, accountant, accounting manager. So what range? Looking at this 24,000, what is the range of job title in which you will fall into? because this is minimum salary, maximum salary. So this is a range. So I'm saying select last name, salary, job title from employees, join jobs on salary between, I'm now calling, this is the condition, salary between mean underscore salary and max underscore salary. I'm going to qualify it by creating an alias. So for jobs, I will say J. For employee, I will say E. So I'm coming back here to say this last name should come from the employee table, E dot last name. This salary should come from the employees table, E dot salary. This job title is coming from the job table, so J dot job title. From employees, E, join jobs J on salary between. Now, this mean salary will be from the jobs table, which is J. Max salary will be from the job table, which is J. So I'm going to terminate. So I have this, terminate. I can bring it down like I did before. Bring this down here, cut this join, bring it here, cut this on, bring it here, and then cut this between and bring it here. So this is my query. I can equally bring this and down too. So this is my query. Select E, last name, salary, job title from employees. Join jobs on salary between minimum salary and maximum salary. Now let me execute it and you see the output. Now look at the output. Look at this last name, salary, job title. Look at this person and look at the way it arranged it. Okay, now I can now add what I wanted to put, which is the order by clause. Order by last name, meaning as you are bringing out the output, use this last name column, E dot last name. It's already showing that. Okay, so I'm saying when you are bringing out the output, arrange it. You can see this one, you didn't order it, it's just bringing it out anyhow you want. Now, when it's going to order it, it's going to start from the first alphabet. Probably if you have somebody that has A. So I'm now going to run it again. Now look at this. So with this now, look at Abel. Abel's salary is 11,000. Can you see it? This 11,000 is falling within the job range of sales representative, sales manager, purchasing manager, accounting manager, finance manager, marketing manager. Because there's overlapping of this salary amount, assuming there was no overlapping, maybe this one is 30,000 to 40,000. This one is 20,000 to 30,000. You would not have seen it appear that way. This my output would not have appeared this way. Look at it. 11,000 is the salary of Abel, right? This 11,000 come here to job 11,000. Now, you won't see it as president because 20,000 is above 11,000. You won't see administration vice president. So Abel can never fall into the job title of president with that salary. He can never fall into the job title of administration vice president with that salary. But look at, and then his salary is 11,000. It will not fall into administration assistant because this is 3,000 to 6,000. Now, he's falling into finance manager because finance manager salary is between 8,200 to 16,000 and Abel's salary is 11,000. Can you see? That is why you are seeing that when you run this, Abel fall into finance manager. Do you understand? Abel fall into finance manager. Then I will run this again. You look at another one. Now look at Abel will not fall into public accountant because his salary is 11,000 and this is between 4,200 to 9,000. Sales manager. Now sales manager salary is within the range of 10,000 to 20,000. So Abel can also fall into the range of sales manager. Sales representative is between 6,000 and 12,000. Abel's salary is 11,000. So he can also fall within the range of sales representative. Then purchasing manager. Purchasing manager is between 8,000 and 15,000. And Abel's salary is 11,000. So he can also fall within this range. Now, purchasing clerk, it can never fall within this range. Now, if you scroll down, you see this is 9,000 to 15,000. Marketing manager, Abel can also fall within that range. And then that is it. So that is why when I run this, you are seeing Abel. Abel can fall within the range of sales representative, sales manager, purchasing manager, and accounting manager. Because I wanted to see the range in which each of the employees, based on their salary, fall into, I had to use the between operator. So I'm picking this salary on, and this on salary here should also have been on E dot salary. See, E dot salary. The reason why it didn't give me an error is because if you look at this job, you can't find salary here. Assuming there was salary in this table, it will throw me ambiguity error when I didn't specify. So here now, even when I didn't put it, it did not give me any error. But putting it is giving me the output accurately, still like before, because there's no ambiguity. He knows that salary is only from the employee table. Now, Cartesian. A Cartesian product is formed when a joint condition is omitted. This is straightforward. You will see it. A joint condition is invalid. All rows in the first table are joined to all rows in the second table. Now, what we use, if you look at this generating Cartesian product, look at these two tables, employees table and department table, and this one is row 20 and this one is row 8, which is 20 times 8, that is 160. Now, in our own case, our tables are more than that. When you look at this employee table, you execute it. How many rows do you have? You have 107 rows, right? When you execute this one, how many rows do you have? You have 27. You know, you can also call a function to achieve that instead of this scrolling that I'm doing. I can just call the function count, and then I put this in parentheses. And then I can also call the function here count. You know, that is, you remember. So I can count, select count from employees, select count from department. So when I do this one, see, it's telling me that I have 107 employees. When I run this one, it's telling me that I have 27 employees. Now, what is the Cartesian join going to do? It will simply multiply 27 times 107. That will be 2,889 rows. That is what will be returned. Okay, so let's write a query to achieve that. Now I come here and I say select star from employees. Now, the join condition that we use to achieve a Cartesian product is known as cross join. Cross join. So I will just say cross join department. Then I will end it. Right? Select star from employees, cross join department. When I end it, I execute. Look at it, brings this out. So I'm going to scroll down to see how many rows it's going to return. See, it's returning 2,889, which is what we got in our calculation. That is 107 rows in the employee table multiplied by 27 rows in department table. So how did they achieve this? What he's going to do is every row in the employee, look at how we achieve that volume. Stephen, right? Now, Stephen will have to be multiplied with all the rows in the department table. Then Nina will multiply with all the rows in department table. So you can see, if you look at this, you will see Stephen multiply with all the rows in the department table. Then after that, so Stephen multiply with all the 27 rows. The second row in the employee table will multiply with all the 27 rows in the department table. So the total of that is just multiplication. 27 times 107, and it's giving you 2,889. Now, what do you need this type of data for? It's not useful. The only usefulness of this type of data is when you are going to supply it as an input to another experiment that you are doing. And that your research requires you to supply heavy volume of data. So you can just write a query like this to generate this data. You can see I'm generating 2,889 rows. I will now feed this to another query that will be able to carry out that research that I'm doing. So you only need this kind of output for when you want to produce, when you need huge amount of data to carry out a research or an experiment. Anything other than that, you don't need a query of this nature. So that is that. So in the next class, we are going to look at the last part um, of join, which is actually what? The outer join, which is the right outer join, left outer join, and the full outer join. That one will be to explain to you if you are combining two tables together and the columns are not matching, and you want to bring out every information from the first table and every information from the second table. So that is when you use outer join.